So we're going to look at series parallel. And that's spelled wrong. Series is one path. You have one path. Parallel, you could have multiple paths. If a break in the circuit here, everything would go out. If there was a main break in this circuit, it wouldn't. Okay, so that's the biggest thing. One single path. We're going to take a look. Two light bulbs in series versus parallel. So we'll go ahead and draw that. Again, the schematic. If I have a battery, let's say a light bulb, I'm just going to draw a resistor symbol to make it simple, another resistor symbol to make it simple, and one more, and then maybe a switch. Okay, we'll say we have a 9-volt battery. Let's say this is 5 ohms, 10 ohms, and 5 ohms. Whenever you approach these problems, this is a series circuit. The current goes in one path only. Whenever you approach these problems, you want to find the total resistance first. So our total for a series circuit is resistor 1 plus resistor 2 plus resistor 3. We'll just label these R1, R2, and R3. Okay? Very simple. You add up 5 ohms. Please use units. 10 ohms plus 5 ohms. The total resistance is equal to 20 ohms. I would put that at the battery. So the total resistance measured here would be 10 ohms. We can calculate that. We can also measure it with a multimeter. The total voltage, let's just make it simple. Total voltage is 9 volts. And then you also want to figure out the current. Okay? We will figure out each of these, resistor 2, volt 1, current 1, volt 2, and current 2. Volt 2 and current 2. But again, you want to, step 1 is to find total resistance. Step 2 is find total voltage and current. Step 3, actually step 0 would be draw a schematic and your finds and your givens. You always want to write this out. So draw your schematic, your finds and givens, find your total R. This is a series circuit. Please write all this down. And then you'll find your total V and I. Well, your voltage was given. Okay, so what you can do then is use V equals IR. That's a great equation. We also gave you another tool for your tool belt. Total resistance. Those are really the only two you need. Okay, so finding the V equals IR, and I'm going to have to get a calculator out here. Let's just get that out. Sorry, V equals IR, so 9 volts equals I. I meant 20 ohms here. Nobody's there to correct me. So I would just be 9 over 20. 9 divided by 20 equals 0.45 amps. Amps will probably be a small number. Actually, it's pretty big for this, but 0.45 amps. Then, third step, you'll find individual voltage, current, and resistances in each spot. You could have light bulbs, motors, whatever it is. I just use generic resistors. So again, resistors are given, okay, for a series circuit. I total right here is going to be the same. I1, I2, I3, etc. Voltage, you add it all up. V1 plus V2 plus V3. And the way I remember that, there's an I in series. Parallel is going to be different. So guess what? I can fill this in. 0.45 amps, 0.45 amps, 0.45 amps. Well, guess what I do with the voltage at each spot? I can use V equals IR, V equals IR, V equals IR. There's also a PowerPoint that shares with you, oops, I didn't mean to do that, the rest of the PowerPoint, and it tells you the characteristics. The series circuit has the total resistance, you add it all up. The voltage you add up, and you can check yourself when you find that out. You can go back and add these volts. Oh man, you guys, I put this in the wrong one. That's okay. 0.45 amps, always use units. You can add these voltages up and check yourself. I'm not going to do that because this is just a how-to video, but that's what you would do there. And then it also says the current is equal to itself. Remember, amps, 1 amp, 1 volt equals 1 amp times 1 resistance. If you have milliamps or you have kilo ohms, you have to change them. And then the last tool for your tool belt is 1,000 milliamps equals 1 amp, or 1,000 ohms equals 1 kilo ohm. So you have to make sure that they're in amps, volts, and ohms. Good luck and have fun.